आमे देखिबा what are the failure causes for a gravity dam. Mainly 4 type of causes are there. 4 प्रकार forces द्वारा gravity dam टा fail हुए. 4 प्रकार cause अच्छी जार gravity dam fail करे आपे. By overturning, crossing and development is tension. Last one is the shear failure. So by overturning, first case if the resultant of all the forces acting on a dam passes through outside the toe, the dam shall rotate and overturn. जोटा कि practically केबे भी हुए ना possible नुह कहीं ओवरटर्निंग हेबा आगुरु डैमटा बहुत आगुरु कंप्रेशन ने फेल हो जाइथिबो. And this factor of safety against overturning varies between 2 to 3. Next cause of failure is the compression or crossing. Compression and crossing by आमे जाको कोचे compression failure that is due to the compressive force acting on the dam. आमे जेटा कि already जानी छे compressive forces on a structure that are due to that is calculated by the P max and P min equation, that is equal to summation of vertical force divided by base into 1 plus minus 6e by b is the eccentricity of the resultant force. Eccentricity means at from center at which distance the force acts. Summation of vertical forces is summation of b and b is the base width. This is the figure which shows the force distribution or stress distribution for the compressive forces. First case when the reservoir is full, this is the stress distribution P max, P min. Sometimes P min may be negative, which is the cause of tension. Second case, stress distribution due to when the reservoir is empty and resultant nearer to the hill where the P max is there, and here also P min will be negative when the tension arises. Next is the failure due to tension. So mostly gravity dams are constructed of concrete material and concrete cannot take tension. So failure of tension is not practically at all possible because dam is designed so that the tension failure should not be there. सेमती तैयारी होइथिबा दरकार डैम टा जेमती केमती तैयारी करा जायता जेमती कि टेंशन केबे भी डैम रे हबनी काने कंक्रीट केबे भी टेंशन नहीं परिबनी. तो maximum permissible tensile stress should be taken 5 kg per centimeter square. 5 kg per centimeter square. If some cases where tensile stresses, some tensile stresses develop, then there will be tension cracks in dams. And tension cracks in dams, जोटा कि डैम को तो किसी नष्ट करिवनी, but it is the cause of the failure. It leads to failure of the structure. जोटा कि excessive compressive forces produce करिवा, which will cause failure in the dam. So in order to ensure there should be no tension, the P min आमे जोटा compressive stresses calculate कला वाला decide कले P min should be equal to 0 so that there won't be any negative stresses and P min is equal to 0. Summation of V by B 1 minus 6E by B, that is equal to 0, from which we get E is equal to B by 6, or eccentricity should be 1 by 6th of the base width. And the last cause of failure is the sliding failure or the shear failure, which will occur when the net horizontal force above any plane in the dam or at the base of the dam exceeds the frictional resistance developed at that level. The frictional resistance developed between two surfaces equal to mu into summation of vertical forces. We use the coefficient of friction, we all know, and it should be some sigma h less than equal to mu sigma v, or mu sigma v by sigma h should be greater than 1. Mu sigma v sigma h is the factor of safety against sliding, which should be greater than unity. In low dams, the safety against sliding should be checked by only for friction, but in case in high dams there is extra factor to control the friction, to control the shear strength, an extra factor is taken, and for which the factor of safety against sliding by shear friction factor is measured by the equation mu sigma v plus bq by summation h. B is the width of the dam, Q is the average shear strength of joints, which varies about 1400 km per meter square for poor rocks and 4000 km per meter square for good rocks. And the value of mu generally varies from 0.65 to 75. And this is the figure. This is the figure of the dam structure where horizontal joints are provided to prevent the dam from sliding or shear failure. And this is the rock foundation, and these are the horizontal joints which are provided for sliding, to prevent sliding or shear failure. All these are the causes of failure in case of a gravity dam.